All right, welcome back to Math 1500, Applied Business Mathematics, Connecticut State Community College. And in this video, we're going to look at annuities, loans, and bonds. What an annuity is a savings vehicle, a financial instrument where you're making regular payments. So in our previous video, in section 3.2, we looked at investment where I would take a lump sum of cash, say $5,000, put it into an account, and save that money for 20 years. What will my account be worth? Some people save that way, and sometimes you have a chunk of cash that you'll put into an account. More commonly, what's going to happen is I invest $100 a week or $100 a month, and it goes in each month over time. So you'll see we have a slightly different formula here, where our future value is equal to the payment that we make times, and then this fraction, 1 plus I to the n minus 1 over I. The reason for that, I is the interest rate. Actually, I'm going to look down a little farther where I've adjusted the formula. Instead of I is the R over N, right? For R is the interest rate, N is the times per year that it's being compounded. This is the formula that I will refer to more, this one down here, where the future value equals the payment times 1 plus R over N to the NT minus 1 over divided by R over N. This would be like, so suppose I put money into this account for 20 years. The first amount of money I put in will be invested for the full 20 years. The next $50, next amount of money I put in is going to be available only for 1 month less than that. So instead of 240 months, it'll only be there for 239 months. So things change over time. For the purposes of this course, for those of you watching this for my Math 1500 course, I will not be expecting or requiring that you crunch the formula. If you want to put the numbers into the formula and try to calculate on the home screen of the calculator, you may do that. If you recall in our previous video, I showed you how to go to apps on the graphing calculator. Number one, finance, and then we're going to select the TVM solver. And we're going to do all of the problems in this video using the TVM solver. And I'll show you how to do that. So let's look at some examples. Example 1, at the end of each month. Okay, so again, if you notice all the way down at the bottom here in the TVM solver where it says payment, end or begin, everything in my videos are going to be as if we put our money in at the end of the month. Our payment is due at the end of the month. Interest is paid at the end of the month. If you have an account or you have a situation where you're putting your money in at the beginning of the month, you would simply switch that payment to begin. So at the end of each month, we're going to invest $50. So our payment now is $50. We're going to put that into an account earning 2% interest compounded monthly. And you'll notice I had other numbers here I'm changing as we go. Also, in my previous video, I had mentioned to you that this P/Y is payments per year, where the CY is compoundings per year. It's important now that our PY and CY each match. So notice at the end of each month, we're putting our $50 into our account, so our PY is 12. Also, our 2% interest is compounded monthly, so the PY and CY should both be 12. Our present value or initial value is 0, because you'll notice in this account, I'm not saying that we started with $200 in the bank or $1,000 in our account. So our present value, our starting value is 0. We're going to invest money into the account monthly for 5 years. So that's 12 times per year for 5 years for a total of 60 months. And we're going to go down to our future value, alpha solve. And you'll notice that the value of that account will be $3,152.37. For those of you who, again, are taking this for purposes of course, and you've got a test coming up with me, I'm okay in my test if you just give me the numbers. But again, there's no opportunity for partial credit. I don't know what you did right or wrong. So you might choose to say, N is 60, I percent equals 2, PV equals 0, and so on, that you give me those numbers in the TVM solver so that I know what it is that you entered. And I can double check and see where you made a mistake if in fact one was made. Okay. Example 2, suppose I invest $200 monthly. So my payment is $200. My present value is 0. I'm putting this into an account paying 4.2% interest compounded monthly. So since I'm putting my money into the account monthly, my PY is 12. Since the interest is being compounded monthly, my CY is 12. How much will my account be worth after 10 years? Again, 12 months per year for 10 years. Multiply that as 120 months. And now all I need to do is go to my future value, alpha, solve. And after 10 years of putting money into my account monthly, I will have $29,762.62. Okay. A couple of things that I would like to mention is recall from previous videos that I hope you've watched that the PV is 0, yes, but the FV is negative because that's as if I'm taking the money out of the account at the end of those 10 years. So I'm making withdrawal. So that negative sign is for direction. If you want to know how much interest that you earned over the life of the loan, well, you can go back to the home screen of the calculator and remember I made $200 deposits each month, 12 times per year for 10 years. So I've invested $24,000 into this account, $200 at a time, and now my account's worth $29,762. So I do 29,762.62, and I subtract that, or I subtract the amount invested from that, I will have earned $5,700 in interest. Okay. Let me go back to my TVM solver. So apps, finance, TVM solver. Same investment. I'm investing $200 a month. So my payment's still $200 a month. At 4.2% interest, compounded monthly. My payments are monthly. How long will it take for that account to be worth $50,000? In this case, I want my future value to be $50,000. But here's the key: don't forget, you want to withdraw $50,000. So that needs to be a negative $50,000. How long will that take? Alpha solve. That's going to take 179.9 months. Or if you want to round that to 180 months, you can do that. And I know that it's months because my PY and CY are both 12. So I know I'm talking about months. If I want to know how many years that is, simply divide that end value by 12. And notice it became 14.99 years. So that's approximately 15 years that it will take for that investment to be worth $50,000. Again, we're looking at the value of the increasing annuity. I'm putting money in each month. My investment's going to grow. I am showing you this on the TVM solver. You've got the formulas up above if you want to substitute values in and do the multiplications. Very few people are actually going to crunch those formulas without using a TVM solver, either on a graphing calculator, an app on your phone, or a program on your computer. Okay. Now you'll notice here we're looking at the future value of an increasing annuity with a current present value. So those first 3 examples we did, I'm starting with 0. In a previous video, we looked at the first part of this formula, PV times 1 plus R over N to the NT. If I put $1,000 into an account, how much will my account be worth? That's the first part of this formula. Up above, we were working with, or earlier in this video, just the second part of this video. So suppose, look at example 4. I'll scroll up in a moment. But if I look at example 4, my current retirement account, or my retirement account currently has $5,000. So I would be using this first part to say, if that $5,000 in my account is earning 5% interest per year compounded monthly, I could figure out what that's going to be worth. Or if at the end of every month for the next 10 years I deposit $100 into the account, I would use the second part of that formula in order to find out what that portion will be worth. I can do it all together in one formula. Fortunately, the TVM solver will also handle that. It's only one slight adjustment. My retirement account has a present value of $5,000. With the TVM solver, that's the only adjustment I need to make in order to have or to consider an annuity with a current present value greater than 0. My account is earning 5% interest compounded monthly, so my CY needs to be 12 right there, which it is. Okay. At the end, so end payments at the end of every month for the next 10 years, I'm going to be making monthly payments. So my PY is 12. I'm going to be making monthly payments of $100 into the account, and I'm doing this for 10 years monthly. That would be 120 months. The future value of my account, alpha solve on the future value, will be $23,763.28. Okay? So really, it's not a huge change. If I invest an initial $7,000 into an account, and then I also contribute $50 per month into an account earning 5.5% interest compounded monthly. So again, notice my contributions are monthly, my interest is earned monthly, so my PY and my CY down here, they're both still 12. How much will my account be worth in 15 years? 12 months per year for 15 years is 180 months. So my future value is $28,160.37. Okay. It's fairly straightforward with the TVM solver. Okay. But I want to look at some other examples that we can look at here. So we're going to talk about Bob. He's currently 35 years old. He hopes to retire at age 65. Unfortunately, Bob has not yet begun to invest for his retirement. Suppose that Bob makes an initial deposit of $10,000 into an account earning 8.3% interest compounded monthly. What will his account be worth in 30 years? Notice that he is not making monthly contributions. So Bob is going to deposit $10,000 into his account paying 8.3% interest compounded monthly. So my CY stays 12. What will his account be worth in 30 years? Well, 12 months per year for 30 years is $360. But also notice that Bob is not making monthly payments, or he's making monthly payments of 0 if you want to think about it that way. What will his account be worth in 30 years? His account would be worth $119,583, and we'll call that 32 cents. Okay. Unfortunately, though, part B, Bob does not have $10,000 to deposit into that account paying 8.3% interest compounded monthly. Instead, he says, I don't have $10,000 to invest, but I will put $75. I can find $75 a month. What will that account be worth in 30 years? Pretty close to the same, but $1,000 less, $118,825.28. So that's pretty close. Now you'll notice in example A, part A, it says example 1, 6A, Bob's total investment was $10,000. In example B, it says 1B, but we mean 6B, what was Bob's total amount invested? Well, here he invested $75 12 times a month for 30 years. So Bob invested $75 a month per month for 30 years. His initial investment, out-of-pocket investment, was $27. Whoops, I don't want to put that there. His investment out of pocket was $27,000. Okay. Which is the better option and why? Clearly, investing $10,000 initially would be a better option because Bob's going to make similar money with a much smaller investment. However, given a life situation, if Bob doesn't have the $10,000, but he can come up with $75 a month, the second would be the better option. So it kind of depends on your life situation. For those of you going into finance, your client's current financial situation is something that you'll definitely be taking into account, and this is one way to look at that. Okay. Suppose Bob doesn't have $10,000, but he's got five. So let's go back to our TVM solver. He doesn't have the $10,000, but he's got the $5,000 that he can invest. And he also has been able to scrape together $100 a month into this account. What will that account be worth in 30 years? This would be the best of both worlds. Now notice he's going to have $218,225.37 in that account. So really doing a little bit of both is the same. Starting with some money, putting some in each month. A couple more examples. And these are independent of the ones we've looked at so far, but assuming an account will earn an annual rate of 8% interest compounded monthly. So we're going to earn 8% interest compounded monthly, so my CY remains unchanged. How long will it take? So it's the N I'm going to solve for an account to grow to $250,000 if $300 contributions are made monthly. There's no mention of an initial amount, so we're going to assume that our present value is 0. We're making $300 contributions monthly, so PY stays 12. We want our account to be worth $250,000, so again, we want to withdraw $250,000 at the end of the 30 years. What do our monthly contributions need to be? If I make a contribution of $167.74 into that account, after 30 years, I will have $250,000. Okay, it's not a bad deal. Number 8, assuming that account is going to earn 8% compounded monthly, how much should be contributed monthly to be worth $250,000 in 20 years? So it's the same question. But I don't want to wait 30 years. I want to get there in 20 years. So that's going to be 12 months for 20 years. I would need to make $424.43 per month payments. Notice the stark difference waiting that extra 10 years. Those of you that are young, start investing now. Okay? Number 9, an investor hopes to increase his retirement account to $950,000 by the time he retires 10 years from now. The present value of his account is just over $250,000, $259.12. He is expecting his interest or his investment account to earn 13.16% interest. Clearly, he's not in a savings account. He is in some pretty aggressive investment account, however, and those can be found. Interest is compound monthly. Now, he wants this investment that's currently worth $250,000 to be worth $950,000 in 10 years. Okay, 12 times 10 is 120 months. So 10 years from now, assuming he can keep getting that 13.16% interest, his current investment of $250,259, he wants it to increase to $950,000. So he's got to make monthly payments. How much? That's not bad. $95.69 per month will help him accomplish his goal. Notice that $700,000 is not just from the monthly investments, it's also from the growth of the current investment he's got growing. Okay, there's just a quick look at an increasing annuity from the previous video where we looked at taking $5,000 and investing it, where the change now is we're adding monthly payments amount to that. In our next video, please come back for that one. We're going to look at decreasing annuities, which would be the cost of a loan. If I borrow money, what I'm going to pay for a car loan, a truck loan, a home loan, and various loans of that nature, as well as investing for retirement and mortgage payments and all that good stuff. So I hope to see you back for the next video. Thank you very much for watching.